GIS Fundamentals, Section 3, Geodesy, Projections and Coordinate Systems, Questions. Question 1. Describe how Eratosthenes estimated the circumference of the Earth. What value did he obtain? Eratosthenes noticed that on a summer solstice, the sun at noon shone to the bottom of a deep well in Syene near the Tropic of Cancer, and that the sun would be exactly overhead during the summer solstice. He also observed 805 kilometers north in Alexandria at exactly the same time a vertical post cast a shadow. The shadow of the post defined an angle that was about 7 degrees 12 minutes, or about 1/50th of a circle. Eratosthenes deduced that the Earth must be 805 multiplied by 50, or about 40,250 kilometers in circumference. Eratosthenes' estimate differs from our modern estimates by less than 4%. Question 3. Assume the Earth is approximately a sphere, not an ellipsoid. Also assume you've repeated Posidonius' measurements. What is your estimate of the radius of the Earth's sphere given the following distance-angle pairs? Note that the distances are in meters, the angle in degrees, and calculators or spreadsheets may require you enter angles in radians for trigonometric functions. 1 radian equals 57.29577795 degrees. So, you get the radius by dividing 1 radian degree by the angle and multiplying that by the distance. And then the circumference is 2 pi the radius. The answer to A is 6,357,622 meters. Answer B is 6,354,417 meters. Answer C is 6,367,415 meters. Question 4. What is an ellipsoid? How does an ellipse differ from a sphere? What is the equation for the flattening factor? An ellipsoid is an elongated sphere. An ellipse is a 2-dimensional oval shape. A sphere is a round 3-dimensional object. The equation for the flattening factor is F equals R1 minus R2 divided by R1. Question 5. Provide 3 reasons why there have been various estimates for Earth's ellipsoid radii. 1. The Earth is too large for humans to accurately measure with tools. 2. The land is separated by vast water bodies. 3. Geographic measurement tools and methodology have changed. Question 6. Define the geoid. Tell how it differs from the ellipsoid and from the surface of the Earth. Describe how we measure the position of the geoid. A geoid is usually defined as a gravitational equipotential surface chosen as our base for measuring heights. It is an approximately spherical surface for which the force of gravity is a specified constant value. An ellipsoid is a mathematically defined surface, while a geoid is measured and represents a natural force. The surface of the Earth is also a measured surface, but doesn't correspond to a gravitational surface because geologic forces have pushed surface materials above and eroded them below any given equipotential value near the surface. We have measured the geoid from both near-surface instruments called gravimeters that measure the gravitational force and by gravity effects on satellite motion through space. Question 7. Define a parallel or meridian in a geographic coordinate system. Describe where the zero lines occur. A parallel is an imaginary line that runs east to west around the Earth. It is also known as a line of latitude. Parallels are measured in degrees, with 0 degrees latitude being the longest parallel, 90 degrees latitude being the North Pole, and negative 90 degrees latitude being the South Pole. A meridian is an imaginary line that runs north to south around the Earth, crossing the North and South Poles. A meridian is also known as a line of longitude. 0 degrees longitude crosses over Greenwich, England. Question 8. How does magnetic north differ from the geographic North Pole? Magnetic north is at the point where lines of magnetic attraction converge. And a weightless magnet, if suspended in a frictionless media, would point straight down towards the center of the Earth. Magnetic north is currently located near Greenland. The geographic North Pole is the northern intersection of the Earth's axis of rotation with the Earth's surface. It is located in the Arctic Ocean. Question 9. Define a datum. Describe how datums are developed. A datum is a reference surface consisting of a set of points on Earth that are used to measure other locations. A datum is developed by first specifying the origin point, orientation, and radii of an ellipsoid. Then, highly accurate reference points are measured and recorded in reference to the ellipsoid. The precisely surveyed reference points are called benchmarks. Question 10. Why are there multiple datums, even for the same place on Earth? Define what we mean when we say there is a datum shift. Multiple datums exist because we have improved datums through time, and because we develop different datums for different purposes. Datums are required for measurements, and so most governments estimated datums when a sufficient number of points were surveyed. Additional points with improved methods will lead to subsequent estimations or versions of national datums, in most cases with higher accuracies. Satellite and other measurement capabilities developed in the second half of the 20th century added global datums, increasing the number of available datums for most locations. Question 11. What is a triangulation survey, and what is a benchmark? Triangulation is the process of determining the location of a point by measuring only angles to it from known points using trigonometry. A benchmark is a precisely surveyed reference point. Question 12. Why do we not measure vertical heights relative to mean sea level? Sea level is no longer used as a reference height because sea level is rising. So, the mean height would depend on the length of the measurement record and is not stable. There are local variations due to persistent currents, changes in temperature, or changes in salinity, and sea level varies on a 19-year tidal cycle. Technologies have developed such that we can quickly and easily measure accurate height differences smaller than these sources of sea level variability. Question 13. What is the difference between an orthometric height and a dynamic height? An orthometric height is the distance from the geoid up to a point. This measures the location relative to the ground. The dynamic height measures the change in gravitational pull from a given equipotential surface. Dynamic height measures gravity. Question 22. What is a developable surface? What are the most common shapes for a developable surface? A developable surface is a mathematical, geometric surface onto which points are projected from a spheroid or ellipsoid. This developable surface may be mathematically unrolled to depict a flat map. Planes, cones, and cylinders are the most common developable surfaces. Question 27. Describe the state plane coordinate system. What type of projections are used in a state plane coordinate system? The state plane coordinate system is a standard set of projections for the United States. It specifies Cartesian coordinate systems for each state. There are one or more zones in each state with different projection parameters in each state plane zone. Multiple state plane zones are used to limit distortion errors due to map projections. State plane coordinate systems use two map projections, the Lambert conformal conic and the transverse Mercator projections. State plane coordinate systems are based on NAD 83 and used to use NAD 27. Question 28. Define and describe the universal transverse Mercator coordinate system. What type of developable surface is used with a UTM projection? What are UTM zones? Where is the origin of a zone? And how are negative coordinates avoided? The UTM coordinate system defines map projections for all portions of the globe. Areas between 80 degrees south latitude and 84 degrees north latitude are divided into 60 wide zones, each zone running from the equator to the northern or southern limit. Separate transverse Mercator projections are fit to each zone. Negative zone values are avoided by specifying false eastings and northings. Coordinate values added to intermediate projection coordinates. Question 29. What is a datum transformation? How does it differ from a map projection? A map projection conversion requires the coordinates to be converted back to geographic coordinates and then converted to the new projection. If the current and target projections use different datums, a datum transformation must be used when the data is converted to the geographic coordinates. A map projection conversion with the same datum is a two-step process. A map projection conversion with different datums is a three-step process. Question 32. Describe the public land survey system. Is it a coordinate system? What is its main purpose? The public land survey system is not a coordinate system. The PLSS divides lands into townships, which are divided further into quarter sections or 16th sections. The PLSS is a standardized method for designating and describing the location of land parcels. It was used for the initial surveys over most of the United States after the early 1800s. Therefore, nearly all land outside the original 13 colonies uses the PLSS.